All right, welcome to Wednesday. We are going to finish up the problem that we didn't finish, and then we go from there. So I think where we left off is me asking you if you can punch these into your calculator, see if they're positive or negative. That's all we care about, positive or negative. Positive, great. Then we do something with it. If it's negative, so we got to get out a calculator. Kind of interesting when I say like you got to see if it, yeah. Let's see. Anybody need a calculator? How about that? Because I fixed 3 of them, so we're good to go now. Here. So I got 3. I accidentally. Your choice. Look at that, right?
Oh, okay. Well, the negative 1 is not an answer.
Did actually say that? I wasn't sure if I was supposed to say it.
The minus 1 isn't an answer because it's greater than negative 1.
It's clearly necessary to read 2 books.
Okay, let's go with it here. So I have this right here.
Oh, yeah.
Negative 1 plus root 3 over 2 is
0.36.
6. Okay, that's cool. That's good enough for me for now. Boom. Guys, real quick, let's go with it. Negative 1 minus root 3. Divide by 2.
It's negative 1.4, but that doesn't work because it's greater than negative 1.
Awesome, done. We can reject that already here. It has to be between negative 1 and 1. So that's not going to work already here. So this is the one we got to focus on right here. We do have cosine 4 theta. So now the question is, which quadrants is cosine positive in? I don't know.
1 and 4.
I'll go with 1 and 4. I can go like this here, and I'm going to have to go on the next slide here. So 1 and 4. Cool. I'm going to go next slide. Just give me some room here. So boom. Myself some room. So I'm looking for the angle measurement that gives me a cosine value of 0.366 degrees-ish. And on the calculator here, what we do is we always take the positive value of it because we want to find our reference angle. Remember that? And then we can figure out wherever it is. So if it was a negative 0.366, we would still find the reference angle at a positive 0.366. And then we'll just put it into quadrants 2 and 3. Are we good? Just in case a question just like that comes up on the homework. Strangest thing. Okay, so we are going to have to go like this. Cosine inverse of 0.366, or at least make this as, let's see, how about this on the calculator here? Is it negative 1 plus root 3, right, for 2? Punch that in first, and from there, then we take the cosine inverse of it. All right.
Wait, what were you saying about it going into quadrants 2 and 3?
Let's say we had a negative. Let's say the value that was, it was a negative 0.366. What we do, we still take the positive of it.
Oh, right.
Because we just want to find the reference angle in quadrant 1.
Yeah.
Once you find the reference angle in quadrant 1, then you put it wherever you like.
Okay.
Cool. All right, I'm going to go this way. Let's see.
Wait, but was it negative in the first place?
This one wasn't, but
Okay,
I'm just saying if
just
it
like
was.
hypothetically, yeah.
Yeah.
The other one was, it was a negative 1.4, and we rejected it because it's over the negative 1.
We rejected it because we're mean.
All right, negative 1 plus square root of 3. All that being divided by 2. Yeah, that's cool. Okay, so how about cosine inverse? Oh, hold on real quick here. I got to be in mode, and I am in the wrong mode, I think, because we're in degree mode. Yep, degree mode, in function mode. I think I like that. And then it's going to be second of this little guy right here. So it's the second of the function, because you want to just put in the previous answer, just to be as accurate as you can. All right, Are we good with, let's see, a 68.5? Sweet. All right, I'll leave it up there just to make sure. Everybody got a 68.5 in the calculator? Anybody did not get a 68.5 that tried to do it on their calculator? Big teacher stare at Matthias.
I definitely did.
Oh, good.
Why are you
Okay.
holding your calculator like this?
I
can't
see it for some reason.
Where did it go? Landscape mode calculator.
That'd make graphing a lot easier.
Imagine if it just switched.
That would make that a lot easier. What's a graph? I hate you.
I got a 68.5 here, and then we got to figure out what is that one right there if we go like this.
360 minus 68.
I'll go with that here, 360 minus 68.5. Anybody with that one? Because of height.
291.5.
Okay.
Yeah.
Rounding off to the nearest tenth of a degree, I think that's what it says.
It'd be 291.4707, but 291.
Oh, really interesting little thing here in mathematics. If the answer says, if the question says, what's the answer, right? And you have to do it by calculator. What we normally do is we say it's approximately 68.5 degrees, right? If the answer says, or if the question says, find all the solutions 0 to 360, and then it says round to the nearest tenth of a degree, they're already specifying how much, I don't know, significant figures, right? How much accuracy, right? At that point, you would say it's exactly 68.5 degrees. Are we good? Because you're answering the question. The question was, give us the answer rounded to the nearest tenth. It's exactly 68.5 degrees. Okay, so I got that one. Because it said round already, then I got my two answers and I am good.
So
the
you don't have to do anything with the 4 theta.
And then we got to do the stuff with the 4 theta. And I'm still waking up.
I was like, it's really that long. Wait a minute.
Not complaining, but
Yeah.
Unless they started at the end, so I forgot what was on.
Yeah, I know.
True. Okay, now divide by 4. How about that? And then, oops, hold on. That's not right. Because let's see, what does 4 theta mean?
oh, that it goes
We gotta do-
between 360 times 4 is
How many revolutions do we have?
1,440.
How many revolutions do we have to look at? We have to look at 4 revolutions. Oh no. Okay, hold on. So this is 4 theta is equal to 68.5 degrees. 4 theta is equal to 291.5 degrees. And you guys talk to me. How do we get the other ones?
Add 360.
Add 360 to each one of these guys.
No.
So hold on. Before we do that, before we write it all out as a list over here for a long time, because that'd be too long. If you want to do that, that's fine. But so then if that's the case, how about if we just do this here? I'm going to write it out as 68.5 plus. Remember when we did all of them at the same time? Plus 360K. Do you guys remember that from like way Monday? So let me do this one. Let's divide this by.
Oh, wait.
Hold on.
Wait, the K is in between?
So. Sorry. We're gonna go like this. Why do we do that?
Because we want to get theta by itself.
Want to get theta by itself. The reason, and also the fact that 68.5 is, we're still gonna have to multiply the angle back to that value. We good? So let's do this here. 68.5 divided by 4. What will that be?
17.1.
1 degrees plus 360 divided by 4.
90.
90? Are we good with 90?
Wait, so
And
you're
that's gonna-
saying it's 17.1, so 68.5 divided by 4, and then what did you do?
We divided the 68.5 by 4, and we divided 360 by 4.
Okay. Wait, why did you divide 360 by 4?
Sure. Reason for it is because we know that this hits 68.5 degrees every time it spins around the circle, right? What we're going to do is we're going to multiply by 4 theta. Their angle measurement is going to be 4 times bigger.
Oh, so you have to. bring it
Before we
down
take
just
the
to make it
cosine of it.
theta, but then you have to.
Go ahead, good. You say it,
How-
and I'll say if I
you don't
agree or
know-
not.
I want to say what you're saying, but I don't know how to describe it. in the way that I was. Because at first it's 4 theta, but you have to make it theta. Actually, so you also have to divide 360 down.
Because instead of going all the way around the unit circle each time, you are just taking a fraction of that angle each time. Okay, we're good. Let's try it. So theta, and then let's see, we have 4 revolutions on our hands. So we're going to do k is equal to 0. That's revolution number 1. K is equal to 1, 2, and 3. Talk to me. See if that makes sense.
So it's like where k is equal to 0.
So since we need 4 revolutions, k is equal to 0 is the first one, right? So we're only going to go up to 3 because we just need 4 revolutions, starting at k is equal to 0. So 17.1 degrees, 90 added to 17.1. You can use your calculator. Totally allow you guys to use your calculator. That's fine. Add 90 to add 90 again. Second. 197. Okay. 197.1. Cool. And one more time. Okay, 287.1. Sorry, too fast of a start, huh? We should have went back and did the problem all over again.
Yeah, I'm a little confused.
Yeah, that's right.
You got all the other solutions before you divided it, so why did you do it after this?
Talk to me, George. Go ahead.
Like in problems that we did earlier in this
Mhm.
lesson, we
Mhm.
would we would get all the other values. We would get the first one and then we would add 360 and get all the other values for all the other revolutions, and then we would
Mhm.
divide all of them. So why did we divide first this time?
Sure. Going back over here. If we listed them individually like this, let me just go back. I'm going back, finding out where those pieces are right here. So this is us listing them individually as we are going all the way to 4 revolutions. This problem here, we have, sorry, this is 2 revolutions, right? If we had 4 revolutions, it would be double the amount of solutions. So instead of doing this way and listing all of them, then dividing them by 4 each time, that's why that little k value is easier to handle, because then you just write one solution and then you just reiterate the k values, how many times you need. A little bit better than, again, we have 4 solutions on one end, 4 on the other, so that would have been 8 solutions altogether, right? If it was 8 theta, now you're stringing out 16 different solutions across your sheet of paper and then dividing those by 4. Okay? So it's just a little faster iteration of finding
So
them.
why didn't we do that the whole time? Why did we do it the harder way?
We went from individual solutions. We found, then the next example was the k value, like, hey, let's find all of them, right?
Okay.
And then we went to the more difficult ones, like, okay, this is the way we normally do it because of this can go on to 8 theta, 16 theta, 32 theta. And so the last one is the normal one we do if we get a whole bunch of them. If you're just looking at 2 theta, you may just want to just add 360 and then divide by it and be done. Because 2 theta is really simple. Once you get to 3 theta, 4 theta, 5 theta, it's like, I might as well use the k value and do it that way.
What if we wanted to?
No problem, guys, go for it. I love to see your homework on that.
64.
Okay, this, Does that help? Does that? Okay, we still got to do the other one. Still not done. We have that one, and then we also had, oh, the 291.5. And I'm running out of space here. Okay. 4 theta, 291.5 degrees plus 360 degrees. Divide by 4.
It's okay, it's still 0, 1, 2, 3.
Mm-hmm. We're just doing the next iteration of them. So anybody, 291.5 divided by 4.
72.9.
And that's gonna be 90. Okay. And then so notice now we actually are defining theta for ourselves, right? We're saying, hey, theta is this, and k is going to be these 4 iterations of it. All right, I'll do the tough one, 72.9. Okay, I'll do the next one, 162.9. Can you give me 2 more? Fine, what, 252.9? Fine, 312.9, is it?
I got 340.
3. Okay, look at that, make the 1 into a 4, love that.